for this video, we're going to cover energy accounting CEM questions. So let's get started. We're going to cover a demand charge problem, a ratchet example, and load factor. So in this problem, you find that you can replace 432 watt lamps with 8 watt lamps. All of these lamps are on during peak power usage periods. Calculate the total dollar savings per year given the information below. So these lamps are running 13 hours a day, and the electrical rate is as follows. So the peak rate is $12.50 per kilowatt per month, and the usage rate, or the energy rate, is about 5 cents per kilowatt hour. So the first thing you need to calculate is the demand savings, so from the peak. And the big sort of hint here is that all of these lamps are on during peak power usage periods. So whenever you're thinking about reduction in peak charges, you really need to pay attention to when these things are running. So in other CEM problems, you may not even have any peak power reduction because you may be turning these things off at night when the peak's not occurring. So make sure to really take a look at that. So if we calculate the kilowatt savings, we are calculating that we are replacing 400 lamps, so that's where the 400 comes from, and we're going from 32 to 8 watts, so we take the difference of those, and then we just convert to kilowatts. So we are looking at a peak power reduction of 9.6 kilowatts, and then to calculate the savings in the next line is we take that 9.6 kilowatts and we multiply by 12 months. Now this is the other thing about the peak savings, is they just occur usually once per billing period, or usually the billing period's a month, so that's why you see that here. And then we multiply by the rate, the $12.50 per kilowatt month, and that's $14.40 a year. And the energy savings we have to take into account runtime, and it's in kilowatt hours. So the runtime is 13 hours a day, but we're calculating annual savings, so we multiply by 365 days a year, and then we multiply by the utility rate, which is 5 cents, and that's $2,278 a year. So we would just add those two together to get the total dollar savings. Okay, now that's the ratchet problem. So in this case, a facility has a ratchet rate structure of 85%. In the current billing month, the actual metered demand of the facility was 600 kilowatts. During the previous 11 months, the highest peak demand was 900 kilowatts. What will the billed demand be? Okay, so let's just, the calculation for this is relatively easy, but sometimes it can be a little confusing as to what you're actually doing. So here's the idea. The utility really cares normally about your highest peak demand throughout the whole year, because that's what they need to build the wires for, that's what they need to build the power plants for and whatnot. So they do care month to month what your peak demand is, but they care a lot more about your overall peak demand. So that's why they care about the previous 11 months and what the highest peak demand was there. So what a ratchet means is they're going to charge you one of two things. They're either going to charge you for the demand you use this month, or in this case, since it's an 85% ratchet, they're going to charge you for 85% of your highest demand in the previous 11 months. So, and they charge you, this is the big point, they charge you whichever one is higher. So let's just do the calculation for this case. 85% of the 900 kilowatts, which is the previous 11 months peak demand, is 765 kilowatts. So that's what they're going to charge you in this case. Now, if this 765 kilowatts, if you did that calculation and you got 465, they would charge you for the 600 kilowatts, because the 600 kilowatts is the greatest. So that's the thing to know about this problem, is that when you calculate the demand for the ratchet demand for the previous 11 months and multiply by the ratchet factor, in this case 85%, your build demand is going to be the highest of what your current peak is and what that calculation gives you. Good. So now let's talk about load factor for just a second. So remember, this is the load factor for a day, but it's usually you look at monthly load factor when you're looking at your utility bills. But all load factor is, it has nothing to do with usage. It's a measure of basically the shape of your usage profile. So, and it's a measure of how peaky your electricity use is. So a low load factor means your electricity use is relatively peaky, and a high load factor means it's relatively flat, and it's going to be between 0 and 1. So this just shows you, you know, a visual example of that. So there's a couple different ways we can calculate load factor, but basically they're just, you know, the same idea, just sort of rearranged a little bit. Load factor is kilowatt average over kilowatt peak, and then if you want to, you can do kilowatt average as, you know, the kilowatt hours divided by the hours in the time period. The other way to think about it, if you want to, is the top is the kilowatt hours used in the time period, and the bottom is the kilowatt hours that would have been used in the time period if the peak kilowatt was always used. So again, it's just sort of rearranging the formula in different ways. And load factor can be calculated for any time period, but normally it's done billing cycle or monthly. So let's look at an example problem. If in a given 30-day period, a building uses 500,000 kilowatt hours, if the peak during that month is 1,000 kilowatts, what's the load factor? So using the formula, we plug in the kilowatt hours used in that time period, the 500,000, and then we plug in, you know, the kilowatt hours that would have been used. So if we have a peak, if peak kilowatt was always used, I apologize, that's cut off. So we have 1,000 kilowatts multiplied by 24 hours a day because it would be always used, and we have a 30-day time period. We do the calculation, we get 69.4%. Okay, those are all of the energy accounting problems. Thanks for watching.